In this video, we're going to determine the range of a given function. So suppose that I give you a function like this. Fx is equal to negative x squared plus 1. You know that the domain is all real values, okay? Because the function will be defined for all values of x, be it negative x values, 0 values, or positive x values, right? Well, 0 value. But in any case, this function is defined for all values of x. Now the range, we'll label it R, will be the values corresponding to these values of x. Okay, so all these values of x, when plugged in, will give you a specified range. Okay, fx values produced by the domain values. Okay, so and we can try to graph this. As you should know, this is a parabola. Okay, this is the graph of a parabola. If you draw it in the xy plane, you can just label your major axes. Okay, the x and the y. And if you plug in the value of x in this function, your y value, the function value, will be 1, right? It will be here. And as you should know, when you have a negative coefficient of x squared, if you're dealing with a quadratic function, it means that the parabola will open down. Okay, so it will expand downwards. So what I'm saying is, it will be like this. Okay, and for this reason, you can graphically tell what the range will be, right? The list of fx values corresponding to the domain values, right? You will see that we're dealing with, well, we're dealing with these values, right? So you can draw a horizontal line to estimate the upper bound for the y values, for the function values. It's going to be 1, right? So the range for this function will be at the highest 1, right? So we can bracket it because 1 is included, right? And it cannot get higher than 1, so 1 is the upper bound. And the lower bound, of course, is going to be negative infinity, right? Because as you can see, the y values, the function values, go infinitely down, right? The parabola keeps expanding as the x values increase forever or decrease forever. It doesn't matter. The y values will decrease forever, right? The parabola will keep expanding. So for this reason, negative infinity must be parenthesized like this, right? Because infinity is not a number, so it's not bracketed, it's not an included number, right? Infinity is not a quantity, okay? So this is typically what range is. Sometimes definitely graphing helps you figure it out. Let's provide another example. Let's provide an example like this. Fx is equal to the bracket x. And the bracket x means greatest. Let me write this word better. Greatest integer. So I'm going to separate this from greatest integer less than or equal to x. So you might say, what is the domain? Well, the domain, of course, can be anything, right? It can be any number, any real number. So suppose that if I give you x is equal to 4.5, then the f of 4.5 will be the bracket of 4.5, and as we said that it means the greatest integer less than or equal to x. Okay, the greatest integer less than or equal to 4.5 is going to be 4. Okay, and the same thing if we were to do 3.01, the greatest integer less than or equal to 3.01 is going to be 3. Okay, and so on and so on. So basically, whenever you have a whole number and you have, let's say, just a little bit bigger than the whole number, so, well, let's think of integers. So when you have an integer, so let me give you a negative number. So if I give you, let's say, negative 3.01, okay, it means that we will have to bracket negative 3.01 and the greatest integer less than or equal to x, right? So obviously this will be a step function, and this value, of course, is going to be negative 4, right? Because we're going to the negative direction. We're always rounding negatively, right? Because if you think of negative, well, let's think of positive first so that you'll understand. If you think of 0.1, the greatest integer less than or equal to 0.1 will be 0. But if you think of negative 0.1, the greatest integer less than or equal to 0.1 will be negative 1. Okay? And so on and so on. So for this reason, when we're going negatively, we're rounding down. We're keeping rounding down. Okay, even if we have negative results. So for this reason, you should understand that the function values for whichever x you choose, whether it's integer or not integer, or a rational number or irrational, whatever, you will always have integers. Okay, so the function values will always be integers, and for this reason, we can say that the range is going to be all integers. Okay, so if you were to graph it, if you were to graph this, okay, you would see that it would be a step function, because if you choose 0, you will have a 0. Okay, if you choose 1 for the x, values between 0 and 1, so you will have a function like this, right? This is open, this is closed, this is open, this is closed, and so on and so on, right? And so on and so on. And you do the same thing here, and so on and so on. So we can check this result. We can check this. So when f is negative 0.1, the result will be, well, let's check 0.1. When f is when x is 0.1, the result is going to be 0. When x is negative 0.1, the result will be negative 1, right? So it makes sense how we drew the graph. This graph is absolutely correct. So you can keep drawing it like that, but it should help you see how this function makes sense. Okay, this is a step function. Okay, so this is how you find the ranges pretty much. You will graph whenever you have to help you see the range and understand what range is. And once you know the domain, it's fairly easy to find the range, especially when you graph it. Okay, so please subscribe, and I'll see you in my next video.